guys, this is Unit 6, Lesson 2, two-way frequency tables, and the theme just screamed Hyunjin's new lover video for me, so you're going to get a lot of eye candy. First, let's talk about the difference between categorical data and numerical data. So categorical data is any feature that can be ordered together to create a group. So in this example, these are all shapes, so these would all go in one unit. You could then break them down into like all the squares or all the crosses, all the circles, all the triangles, all the X's, okay? And then numerical data is a quantity that provides a measurement, so anything that can be counted, okay? Like number of people with hats, number of people with glasses, okay? So this is just groups, and this is numbers. So for example, this would be eye color, and this would be number of eyes, okay? So it wants us to sort these into the correct group, okay, either categorical data or numerical data. And when I did this the first time, I got one wrong because it's kind of vague and it could be either. So age is a number, that would be numerical data. Birth month, this is the one that could be one or the other because it could be like August, September, October, or it could be 10, 11, 12. I believe they put it as categorical data. We'll check. Height is a number. Number of pets is a number. Eye color is a category. Favorite superhero is a category, and number of siblings is a number. Let's see if I did it right. Eye color, birth month, and favorite superhero are a category. Number of pets, age, height, and number of siblings are numerical. These are numbers, okay? So here's a check-in. Mr. Proeski's class is preparing for a winter dance concert. He needs to order matching shoes and shirts for his class. The table displays the information. Use the data to answer the question. Describe a column that could be added to include more numerical data. Okay, there's more than one column possible, but the example that they give is you could add an age column, which is a number, so it would be numerical data, or a height column, and both would be numerical data. This one is numerical, this one is categorical, this one is name, so I guess it would be categorical because you could have more than one Abra or Natalia. Here's example number 1. Jaquin recorded weather conditions for a few United States cities on the same November day. The categorical data is displayed in the table below. What categorical variable is used in this table? Okay, we know this is categorical because there's no numbers. Your only options are no or yes. So what categorical variable is used in this table? The categorical variable in this table is the weather condition, which can be divided into 4 groups: snow, rain, wind, and sunny. Okay? You could then regroup all of this information into a simpler table that looks like this. So the only place that had snow was Denver, so Denver is the only place under snow. For rain, you only had Miami. For wind, you had Miami and Chicago. For sunny, you had Phoenix and Chicago. Okay. Grouping the cities by weather conditions can help in planning vacations, understanding climate patterns, and being prepared. These are the same information written in 2 different tables. Okay. One's not necessarily more correct. They're just different. Sorry, allergies. Here's more information about categorical data. The purpose of collecting categorical data is to classify and organize information into distinct groups based on shared characteristics. This can reveal trends, patterns, or other relationships between groups. Here is another check-in. A biology class is learning about genetics. Students are given the task to record the hair and eye color of their peers. The information in the table displays the information that the students compiled. Describe a categorical variable that could replace the hair color variable in the table. So if we wanted to take hair color out of here, what's another categorical variable that we could use? Now there's more than one answer here. The one they chose is you could replace hair color with hair texture, for example. That's still categorical, okay? These are categories. Yes, they're using numerical numbers here, but this is a category, this is a category, okay? Question number 1, using this weather data, if we had numerical information, could we have used this data to make a road safety decisions? Yes, we could use numerical data to make road safety decisions by collecting measurements such as temperature, wind speed, or precipitation amount. This numerical data helps identify specific thresholds that increase hazard risks, such as expecting road debris when wind speeds exceed 50 miles per hour. Here's example number 2, and this picture, this picture is just so special. I mean, wow. It's a doozy. The members of Daisy's fantasy soccer team are listed in the table. She wants to choose players for a 3-on-3 match based on numerical data. Describe which numerical variables she should use to pick 3 players. Now, they don't answer this question. They give you a whole bunch of information. What they said is Daisy can use the numerical data in the average goal percentage and the average number of assist columns. Both columns display numerical measures of performance. If she wants to pick players based on highest goal percentage, she should focus on Steve, Ice Queen, or Sir Forward, because they all have the highest percentage. Okay. If she wants players with more assists, she should pick Ice Queen, Delilah, and Old Blue, because they have the most assists. Finally, if she wants to consider both goal percentage and assists, she should pick Steve, Ice Queen, and Delilah, because they have the highest combined scores. Okay. Here's example number 3. Milos compiles a list of his favorite games. Use the table to answer the following questions. Here's the first question. The cost of massive car barrowing, which is right here, at $29.99 can be classified as which type of data? Massive car barrowing's price, is it numerical or is it categorical? It's numerical, obviously, because it's a number. Okay, next question. Sandbox can be classified as what type of data? It's right here. Is this numerical or categorical? It's categorical because it's not a number. Okay. How could you change one of the numerical variables to make it a categorical variable? The only numerical one is players, so how could you change this to make it a categorical variable? There's more than one answer that you could have. They said you could change the number of players to single player or multiplayer, and that would make it categorical, okay? Because you got rid of the numbers. Here's question number 1. Determine the categorical and numerical variables in this data set. Drag each item to the correct location, okay? So we have this information, and we have down here, you have to decide if it's categorical or numerical. Pause it, figure it out, come back. All right, the city name is a category because it's not numbers. Precipitation type is categorical because it's not numbers. Average wind speed is numbers, so it's numerical. And high temperature is numbers, so it's numerical. Here's question number 2. Information about the members of a fantasy soccer team is listed in the table. The table includes data on each player's national team. What do you know about the type of data in each column? Does the national team column represent categorical or numerical data? Pause it, figure it out, come back. Information in the national team column is categorical data. Information in the goal percentage and average number of assists column are both numerical because they're numbers. Okay. Here is practice question number 1. At a dog show, dogs are organized and shown by breed. Is this an example of categorical or numerical data? Now this one is going to have drop-down lists that you can select from. I didn't have access to that because I'm just looking at the preview of this lesson, not like the actual test. So is this the breed? Is that categorical or numerical? This is categorical because it's not numbers. This is things like Labrador Retriever, Great Dane. Categorical. And I'm not sure what your answer is going to be for this but it'll be something along the lines of because it's not numbers or because it's a category, or you should be able to figure that part out. Okay. Here's practice question 2. These are at the end of the lesson, so you want to write these answers down and save them for when you actually go in and do your lesson. Ahmad is involved in a project that tracks weather data for the week. He wants to use only categorical data. If he decides to include the measure of the lowest temperature for each day, what type of data would his project now contain? Pause it, figure it out, come back. So we know that his project has only categorical data, and then he's going to add the lowest temperature. What does that tell us? Only numerical data does not make sense because it already has categorical data. Both categorical and numerical? Well, this is numerical. Temperature is numbers. Because temperature measurements are numerical, while other weather factors can remain categorical. This one makes sense. Only categorical? No, because we're adding numbers. We already know that's not it. Neither categorical nor numerical? No, it's both. So there's your correct answer. Here's quick check question number 1. I won't give you the answer to the quick checks because that's cheating, but I'll tell you how to figure it out. Which statement explains how you can distinguish between numerical and categorical data? Well, numerical is numbers and categorical is categories. So go through here and figure it out which one is right. Quick check question number 2. Consider the data provided in the table. Which of the columns shows categorical data? Categorical data is categories, so not numbers. Not numbers. We're not talking about peanuts. Okay, so not numbers. Figure out which one. Univariate data. A credit card company wants to know if its members take at least one vacation per year. This information can be collected through a survey and summarized in the table with simple yes or no responses. This table has one variable, members. Of the 241 members surveyed, there are 152 who take vacations and 89 who do not. While this data is useful, sometimes more detail is needed. So now we're going to introduce bivariate data. What if the credit card company wants to know whether members take children with them on vacation? This situation represents bivariate data because instead of one variable, it involves categorical data that can be grouped by two variables: family type, with or without children, and vacation status, takes vacation or not. This allows for analysis across both categories. Bivariate data is shown in a two-way frequency table, which displays two variables at once. This data compares different categories and reveals details such as how many members take children on vacation. Univariate data tables cannot provide this information. Okay, you should be familiar with this if you've ever used a multiplication table. Okay, these are not hard to figure out. Here's a check-in. For each scenario below, indicate whether you would use a univariate data table or a two-way frequency table. Listing students' scores on a math test. This only has one variable, so this would be univariate. Okay. Tracking the number of students who own a pet in each grade level. One variable, owning a pet. In each grade level, that's 2. I'm sorry. You have owning a pet and grade level, so this is bivariate. Recording the total number of books sold each month. Okay, that's just 1, so that's univariate. Comparing the number of people who prefer coffee or tea separated by age group. So coffee and tea and age group, that's bivariate. Listing the names and phone numbers of the members of your swim team, that's univariate. Okay. Here is a Venn diagram. Venn diagrams compare bivariate data to show how parts of the data relate to each other, like two-way frequency tables do. Consider the following Venn diagram. In this diagram, the circle on the left represents the number of people who prefer pepperoni on their pizza. The circle on the right represents those who prefer sausage, and the overlapping area represents those who prefer both toppings together. The number outside the diagram represents those who prefer no toppings or a different topping. Here's example number 1. How can you show the same information in a two-way frequency table? So this is what the two-way frequency table would look like, pulling information from this. People who like pepperoni and sausage, there were 8 of them. Okay. People who like only pepperoni with no sausage, there were 56 of them. And then if you add these together, you have 64. In this table, the variables are pepperoni and sausage. The variables are separated into which topping or toppings a person prefers on pizza. The row and column headers can be swapped as long as pepperoni stays with no pepperoni and sausage stays with no sausage. So you could have the pepperoni ones up here and the sausage ones over here, and that would be fine, but they have to stay together. It has to be sausage and no sausage, pepperoni and no pepperoni. You can't put like sausage, pepperoni. That doesn't work. Okay. The totals at the end of the rows and columns show the sum of each row or column. Here is a check-in. What is the benefit of creating a two-way table instead of a Venn diagram? A benefit of creating a two-way table is that it shows the same data as a Venn diagram as well as other useful information, such as the total number of responses. So there's more info on the table than the Venn diagram. Completing two-way frequency tables. When working with two-way frequency tables, remember that each row total equals the sum of all entries in that row, and each column total equals the sum of all entries in that column. Also, the sum of all row totals always equals the sum of all column totals. Each of these sums equals the grand total, which represents the total number of observations in the table. Consider the following table and fill in the missing values. So to find this total right here, we're just going to add 35 and 16, and I'm getting a calculator because I don't trust myself. 35 plus 16 is 51, so this total right here is 51. To find this value right here, you can either use this row or this column. I'm going to use this row. So we're going to do 34 minus 22 gives us 12. So this value right here is 12. And you can double check that by adding 16 and 12, which does give you 28. Okay. To find this one, we're going to add 35 and 22. 35 plus 22 gives us 57. And to find this final one, we can either do the row or the column. It doesn't matter. We'll do the column this time. We're going to do 51 plus 34 gives us 85, which is the same answer for 57 plus 28. Okay? Here's question number 1. You convinced your family to get a dog and narrowed your preferred breed down to 2 options. After asking your family and friends for their options, you used the sample data to create a two-way frequency table. Based on this information, which is the most popular choice among your friends and family? Pause the video, figure it out, come back. Using the table, look at the row and column total for each breed. Okay, so Golden Retriever got 20, Border Collie got 18. More people said Golden Retriever, so that is the most popular choice. Okay. Question number 2. A restaurant wants to add a new dish to its menu and is deciding between a vegetarian or non-vegetarian option. The two-way table shows customers by dining frequency, regular versus occasional, and food preference, vegetarian versus non-vegetarian. Summarize your data. Is there a difference between the preferred dish of all customers and the preferred dish of regular customers? Pause it, figure it out, come back. Among all customers, there is a significant preference because 40 prefer a vegetarian dish and 40 prefer a non-vegetarian dish. Okay, regular customers, they put the wrong information, but it says 18 prefer. This is wrong. I love the book. If you look right here, regular customers, 18 want vegetarian, 24 want non-vegetarian. So for regular customers, you'd be better off doing non-vegetarian. Okay. However, if the restaurant wants to appeal to its regular diners, okay, so among all customers, that's what it's saying. There's no difference. Okay, but among regular customers, the preference is non-vegetarian. So if you want to focus on regular customers, you're going to go non-vegetarian. For all customers, it doesn't matter. For occasional customers, you want to focus on vegetarian. Okay? We already did this one. Wait. Yeah, we did this. Okay, question 1. At a drive-in theater's upcoming movie night, the manager is deciding whether to show a comedy or a romance. The manager surveys the community about their movie preferences and records their answers in the table. Fill in the missing values in the two-way frequency table. Pause it, figure it out, come back. Our missing values are 5, 3, and 31. If you need more help with that, comment and I will make another video. Here's question number 2. How many people were asked for a preference? How many people said not comedy? And what movie genre should the theater show for the upcoming movie night? Pause it, figure it out, come back. In total, 31 people were asked for their preference. 13 people said not comedy. Okay, which is right there. 10, ooh, I don't know what's going on with my computer. 10 preferred romance. Okay. And 3 chose neither romance nor comedy. The theater should show a comedy because it was the most popular option. 18 people said comedy, okay, compared to 15 people who said romance. Here's practice question number 3. Use the two-way frequency table to answer the question. What are the missing values? Pause it, figure it out, come back. So for this top one, we're going to do 130 minus 75. Which gives us 55. So there's our first value. You can check that by adding 55 and 84, which will give us 139. Okay, find out this one. You can use either the row or the column. We'll use the row this time. So 152 minus 84 gives us 68. You can check it by going, is 75 plus 68 143? It is indeed. Practice question number 4. Review the two-way frequency table. How many third grade students did not go on the field trip last year? Figure it out, come back. Third grade did not go, 250. Practice question number 5. A community center hosted a 2-day science fair and tracked attendance by age group. They want to analyze the data to help plan future events and understand which days attract different audiences. According to the table, which day had the greater adult attendance? So which day had the most adults? That would be here. And by how many people? And then these have drop-down menus too. So, oh wait, that's the total. That can't be the answer. This is the day that had the greater adult attendance. So Saturday had the greater adult attendance by 15 people. The difference between Friday and Saturday was 15 adults. Okay, you just 145 minus 130. Here's quick check question 3. Use the two-way frequency table to summarize how many total students participated in a survey about whether they liked rock music. So you want the total students. You can do this. I believe in you. You need to figure out where it is. So it's 7th and 8th grade, which is going to be this value right here. So you're going to add something together. I believe in you. Quick check question number 4. Review the table, which includes data about whether people of different age groups like pineapple on pizza. Which of the following statements is true based on the table? Okay, more children were asked the question than adults. More children responded positively than adults. More people overall responded negatively. More adults responded positively than children. So you're going to find each of these on your chart and figure out which one is actually true. Quick check question number 5. Rihanna surveyed people on the street about whether they preferred cats or dogs and then asked for their age. How many people who are 40 years old or younger, so we're using this one right here, said they preferred dogs? So how many preferred dogs? Find it right there and put it in. This is a wonderful, wonderful music video. You should go check it out if you haven't.